Okay, greetings everyone. Welcome in to my channel. I am Professor L, and this is a live stream for math tutoring. So, if you need help with your math, you can post a problem in the chat, and I will do my best to work it out. In the meantime, I have set this time aside to work on my board, and I am just coming up with random topics. I decided to go ahead and I'm going to graph a higher order polynomial again. It's a fifth degree polynomial, and it's one that I came up with. I'm usually typically not that creative when it comes to making up useful math problems. I am creative in other aspects, but not in that one. And so since I was able to kind of just in my mind, I imagined a function, and that was as a result of my mishap leaving my heading up. So I have to be more careful and thorough and not messing up my headings. And I had my last week, I had left up my heading from the day before. It was a totally unrelated topic. And I was just like, this is a big rookie mistake here. And anyway, so I thought about it, and in thinking about that and reflecting, I thought about this function. And then I got to thinking, well, it would be nice to practice expanding a polynomial. And so this function, let's see, we'll say graphing a higher order polynomial, because the method is the same no matter which degree it is. The higher the degree, I think the more complicated it might be. But look, that doesn't even make sense. Graphing a higher order polynomial. So I'll just calm down and take this slow, and no need to rush, and just think about this function that I came up with over the weekend. And I really wanted to do this yesterday, but I talked myself out of it. Let's see, it was x minus 1 quantity squared, x plus 1 quantity squared. So then you would add up all the degrees, and you get a fifth degree polynomial. Well, I came up with this one because I was trying to find a polynomial that would have like clean factors so that it would be easier to graph, and they're more fun to play with, if you have the clean zeros and the intersections. And I was having trouble finding one. Like, I didn't realize I would have that much trouble. I went through my math textbooks, and I asked, the Google AI, and and I wasn't getting a good one. And then I got to thinking, well, I could just make one in factored form. So this is the factored form, and then I could expand it. So that's what I've decided to do today. We'll sketch the graph of it, of course, but in the process of analyzing the function, we'll develop the graph, so that we're devoting some time to playing around with this function. And in the process, practicing our algebra, and fine-tuning those algebra skills, and remembering order of operations and all of the rules that you learn in pre-algebra. What we're going to do is we're going to rewrite this polynomial in its expanded form. So this is factored form, and we want to write that in expanded form. Then we'll take the polynomial. I'll just say x times x minus 1 quantity squared times x plus 1 quantity squared. And then what I'm going to do is I'm going to systematically expand this. When you have a binomial like this and you're squaring it, what that means is it's x minus 1 times x minus 1 because you're squaring it. You're making exact copies and multiplying them. And then you remember that FOIL method, first, outer, inner, last. But what you're doing is you're systematically making sure that each term gets multiplied exactly once. Okay, so x times x is x squared. X times negative 1 is negative x. And then you go to this term and you go here. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. And so then you combine your linear term and you get x squared minus 2x plus 1. And then we'll box that because that is this expression. And then we're going to repeat that process with this number. Okay, so that's going to be x plus 1 times, and I'll move out of the way, x plus 1. Part of me learning and practicing on the board is paying attention to the camera and making sure that you can see what I'm writing. So we have x times x is x squared. X times 1 is x. 1 times x is x. And 1 times 1 is 1. So that's going to lead to x squared. Combine your linear terms. That's 2x plus 1. Box that one. And then we have to multiply these two numbers together. And then multiply, we'll do the x at the end. And you're multiplying 3 terms by 3 terms. 3 times 3 is 9. So you should get, if you multiply correctly, you should get 9 terms as a the product of these two numbers. You should get 9 terms, and that's a check in place to make sure that you kind of done it correctly. And then hopefully there'll be some that we can combine and also possibly eliminate. We'll see what happens. So we're going to take x squared minus 2x plus 1, and we're going to multiply it by x squared plus 2x plus 1. And so we're going to take this first term, multiply it here. And what we're doing is we're systematically making sure each term gets multiplied together exactly one time. And it's kind of a big deal. So this is how I do it. I just do it systematically, the same order every time, and it works out. So x squared times x squared is x to the 4th. And then x squared times 2x is plus 2x cubed. And then x squared times positive 1 is just plus x squared. And then I'm going to move on to the next term, negative 2x. And I'm going to multiply it here first. So negative 2x times x squared is negative 2x cubed. And then negative 2x times positive 2x, well, that's negative 4x squared. And then negative 2x times positive 1 is negative 2x. And then we have one more term. We have this last one to deal with, this one. Let's see, make sure I did that. So we got this one, and this one, we're good. Okay, so 1 times x squared is plus x squared. 1 times 2x is 2x, and 1 times 1 is plus 1. So we'll count the terms. We should have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. So we're just going to go through and we're going to combine any like terms. For a term to be alike, it's going to have the same variable and it'll be raised to the same exponent. So that's kind of a big deal. Same variable, same exponent, then you can combine them, they're like terms. So I only have 1x to the 4th, so I'm going to copy it down. And I'm going to go ahead and cross it out from the above, just so it helps me to keep track of them pretty quickly. So I have positive 2x cubed and a negative 2x cubed. Those are going to go to 0. We're going to cross them out. And then I'm going to go to my next term in sequence. That's a square term. So I have, looks like I have plus 2 minus 4 plus 2. So I like to add the positives and then do the integer arithmetic. It helps me to systematically keep track of my signs. So that's another rule that you keep track of. So you've got 2x squared. So that's 2x squared minus 4x squared, and that's going to give me minus 2x squared left over. And we'll go ahead and mark through those x squared terms. And then it looks like we've got here again, we've got a plus 2x and a minus 2x. Those will go to 0. And then we have a plus 1. Perfect. So we end up with this polynomial. And then what we have to do is we're going to take, this is a result of this product here. These two numbers, we still have this x term to contend with. So we'll just multiply through everything. It gets a factor of x. So we have x times x to the 4th. That's going to give me x to the 5th. And then x times negative 2x squared is going to give me negative 2x cubed. And then x times 1 is going to be plus x. And here is my new function in expanded form. So what I've done is I have created an equivalent function that I can now very easily take the derivative of, which is part of the reason why I did it. Another reason why I did it is because it's very good practice to be able to alter the form of your polynomial. And so, yeah, well, we want to be able to factor it. We want to be able to take it in this form and put it in this form so that we can find the zeros very easily. But we want to be able to go in reverse too. So anyway, here is my polynomial that I can now take the derivative of. And maybe I'll take a break from that. I'll come back and calculate the derivative in just a minute. What I'll do is I'll come back over here to my graph and my Cartesian coordinate system. And I'm going to go ahead and plot these zeros out. The zeros of my function. So what I have here is I have a situation where it's a square, 2 squares. So that signifies bounces. That means that you have a maximum or minimum value on your x-axis. That square term means a lot. That's what it's telling you. It's telling you that not only you have a 0 at that location, that the graph is behaving in a specific manner. So it's like it's sitting on it. Like it's like if you were sitting on a bench or sitting on a fence post or something. I don't know. But what that's telling you is that at that value, that 0, that your graph is bouncing. So I kind of know what to expect. I just don't know exactly which way the bounce is going. 5th degree polynomials have a specific end behavior. So this, your leading exponent is going to determine your end behavior of your graph. And because it is an odd function, it has symmetry with respect to the origin. So if the end behavior would be going from the first quadrant through, or I guess, sorry, through the third, from the third quadrant to the first quadrant, because it's an increasing function. It should be increasing it anyway. So it's moving from negative infinity to positive infinity, if that makes sense. So I know that because it's a fifth degree polynomial, it's going to have that end behavior. I also know that, let's see, I have these zeros. So I'm looking at this specific value here. And what I'm doing is I'm setting my function equal to 0. So I'm saying specifically that, let's see what I want to say, x times x minus 1 squared times x plus 1 quantity squared. This function equals 0. And that is a very specific value. I want to know when the function value is 0, that I'm remembering that that is the x-axis. So if we were going to set up a table, which if you have watched any of my videos, you know that I like the table. Go ahead and set up a table here. But specifically when x is 0 and when y is 0. And when x is 0 is going to be your y-intercept, that because every value on this line, x is 0, and then similarly adversely, your x-axis is when y is 0. So those are your intercepts. All right, so if I'm going to go ahead and first plug in and remember that y equals f of x. Okay, so then you have x comma y in your Cartesian coordinate system, and anyway, it just works out. So in order to find the 0 values, what you're doing is you're just taking these factors individually, setting them equal to 0. So this means x equals 0, x minus 1 quantity squared equals 0. And I also have the x plus 1 quantity squared equals 0. And what this is a duplicate. So this is going to be x minus 1 equals 0, x minus 1 equals 0. We don't need to copy it twice. And this one's going to be x plus 1 equals 0. So on this one, adding 1 to both sides, you get x equal 1. And then this one subtracting 1 from both sides, you're going to get x equal negative 1. So this one, so I have x equals 0, x equal negative 1, and positive 1. So we just say that's negative 1. No one want to go further out? We'll go further out. We'll say that's negative 1. I need to be more careful about my making sure that my tick marks and my units are a little bit more symmetrical. I've noticed in my video I was not happy with my circle. It looked fine from my vantage point up close when I drew it, but when I looked at later on in the video, it's like that. It was really not a circle. It looked like more like an ellipsis. Okay. So I need to just be more careful, that's all. Okay. So we'll just say that's 1/2, 1, 3/2. And this will be negative 1/2, negative 1. -3 over 2. And maybe I'll have a little bit more room down here at work. Okay. All right, so see if that's going to work. So I have my zeros at 0. And I also have a 0 at x equal 1. Let's see. X is 1, y is 0, x is 0, y is 0, and x is -1, y is 0. So we've already got our zeros marked right there, right there. And maybe go ahead and be a little bit more here. We'll say -1. We're going to add some more points in here anyway, but there we go. Those 3 zeros exist so far. And then I think we'll go ahead and take the derivative of this thing, the first derivative, see what's going on. This one needs to be squared over just a little bit, I noticed. Such a big deal, such a big deal. Okay. All right, so recall we have the power rule. So we're going to calculate f prime of x. And using the power rule, we're going to, it's 1 times 5, because the coefficient of x, if it doesn't have 1, is said to be 1, times x to the 5 minus 1. And that's the rule. Pull your exponent down, multiply by the coefficient. It becomes a new coefficient. So 5 times 1 is 5. And then you drop your exponent down 1. And then you can go and separate, and each term you can apply that power rule separately. So this is going to be 2 times 3 is 6, and then 3 minus 1 is 2, and then this is first power, so that's 1 times 1, and then you drop it down, it becomes a 0, so that's just plus 1. Okay, so then you have f prime of x equal this. So there's your first derivative. 5x to the 4th. And I just thought of something. I could find the critical values of this graph. If I can factor this thing. So this is going to give me an opportunity to practice the U substitution. So what I'm going to do is I am going to erase some of this, and I'm just going to do that. So we're going to solve well, I think I can go ahead and use U substitution and maybe the quadratic formula if I can't get it to factor, but I think it might factor. So let's try it. So we're just going to say U equal x squared. So we're going to have f prime. So we'll just say y. Let's use this. So y equal. This is 5u squared, because this term can be rewritten 5x squared squared. That's why 2 times 2 is 4. So that becomes u squared. This one. And then this one's going to be minus 6u. And then that'll be plus 1. And then let's see if we can factor it. 5u, u, So I want that number to be, is it just 1 and 1? Hang on. So let's try it. So then they would both be negative. Let's try. So 5u squared minus 5u minus 1u plus 1. Look, I did it. 5u squared minus 6u plus 1. Perfect. All right, so that's just me checking to make sure I have my factors. So we've got our factors here. So we have 5u minus 1 times u minus 1 equals 0. And then I will set each factor equal to 0. 5u minus 1 equals 0. And u minus 1 equals 0. And then we can go ahead and solve. This is 5u equal 1 divided by 5. So you're getting u equal 1/5. And then this one, plus 1 plus 1, you're getting u equal 1. But now that I have solved for u, I can come back and plug in. So I have x squared equal 1/5. And I have x squared equal 1. So when I solve, I get x equal plus or minus 1. Solve this one, I'm going to get x equal plus or minus radical. Well, that's going to be, hang on. We'll rationalize that. That's radical 1 over radical 5. And then that'll help us to practice our rules for radicals, which are also important. Box this one so it doesn't get lost. And then this one becomes, well, let's see. Let's rationalize this radical first. Let's rationalize. Square root of 1 is 1 over radical 5. So we're going to multiply it by radical 5 over radical 5. Because we're going to remember that when you multiply a number by 1, it's not going to change the value of it. You can multiply by 1 all day long. It's not going to change the value. So anything divided by itself is also equal to 1. So this is very important. It's allowing me to do this. It's not some math magic. It's a logical, very logical. So then you get radical 5 divided by, and then when you multiply two radicals, you just get, so radical 5 times radical 5, that is radical 5 times 5, and that's just 5. So that's allowing me to rewrite this expression like this. And then not forgetting the plus and the minus on there. Okay, so we've got our x values now on our first derivative, which is very nice because what that's doing is the first derivative is telling you critical points on your graph. That's specifically what it's doing. So I knew about these because I did already calculate it was in factored form already. So I already kind of knew about these, but it's also telling me there's a maximum minimum there at those values. So radical 5 over 5 though. So I have plus or minus 1, and then I have this value. So I'm going to figure out, I'm going to use my calculator, I guess. What is radical 5 over 5? Let me see. That is 0.44. Yeah. We'll put it here. 0.4472. Trying to write upside down here. 1, 3, 5, 9, 5, 5. So it's going to be plus or minus this number, essentially. So that is really close to 1/2. It's like in here somewhere. A little bit less than 1/2. Right in here. And we'll put it in there. Negative radical 5 over 5. And positive radical 5 over 5. And then I think that we should be able to plug those values in to the first function and evaluate. All right, what do I want to do next? Oh, I guess we can calculate the second derivative as well. Let's go ahead and put it down here. But we still haven't sketched this graph. So we're just trying to remember what exactly the second derivative is going to tell you. It tells you what those values are, whether they're local maxes and minimums, I think. All right, so we'll just do it real quick. 5 times 4 is 20. And then that's going to be x cubed. And 6 times 2 is 12 minus 12. And that's x. And then that's nice because that plus 1 term is going to drop off and I can factor an x out of this. Nice. All right, I think that this is my second derivative here. So I can also find the zeros pretty easily here on this one. All right, so we're going to go ahead and just factor out an x. So, oh, wait. We're going to factor out, let's see, a 4x. And then so that's going to give me 5x squared. And then that's minus, minus 3. All right. Set that second derivative equal to 0. And then so I have 4x equals 0, which is 0. So x equals 0, which is, I think that's yeah. And then hang on, 5x squared minus 3. Wow, add a room. I guess we'll put it all the way up here. 5x squared minus 3 equals 0. So we're going to add 3 to both sides. So you need 5x squared equals 3 divided by 5. X squared equals 3/5. So we're going to take the square root and we're getting x equal radical 3 divided by radical 5. And then we rationalize radical 5 over radical 5. And that's going to be, looks like radical 15 over 5. Plus or minus. Let me see what radical 15 over 5 is. Put it in there. All right, so calculator says it's 0.7. 0.7745 96692. Okay, good. So let's see. Radical, let's see, 0.7. That is a little close to 0.75, so it's probably in there. Negative radical 15 over 5 and positive radical 15 over 5. What I really want to do is figure out, oh, I'm starting to get lazy. All right. Well, this took me a lot longer than I thought, and I still haven't sketched the graph. So I did find the critical values on the graph here. But what I want to do now is I want to start evaluating this function, which is, I think that maybe that's what I should have done to begin with. So I want to start evaluating the original function at some of these critical values that I've found, so that I can sketch the graph and figure out what's going on. All right, so I guess it's a lot of writing. I'm going to go ahead and erase it because, and let me see what I want to keep. I'm going to keep my derivatives for now. We'll box these. So I will not erase anything that's in a box. This will be fun. Yeah. So evaluating and analyzing higher order polynomials. There, I think the higher the order, the more difficulty it is. And we didn't need synthetic division this time because this polynomial, we started out in factored form, and we would have used this. We used synthetic division a lot, because we've been having to put it in factored form. But it's nice whenever. Okay, but I heard something important. All right, erase all this work, and then yeah, let's begin to evaluate the function and see what's going on. Right, I needed that. I got ahead of myself. All right, if I need it, then I will put it back in there. We'll go ahead and erase that too. All right. And I'm going to go ahead and list the values in my domain on my table that I want to evaluate. We're going to start with -3/2. And we're going to evaluate -1. We already know it's 0. -15. Radical 15 fifths. Negative radical 5 fifths. And 0. We're going to do 0. We already know it's 0. We're going to that one. And then draw a straight line. Positive radical 5 fifths. Positive radical 15 fifths. And that radical is looking a little radical. Positive 1, we also know that's 0. And then we want to do +3/2. Just to make a nice symmetrical. All right. So I'm going to start out doing it by hand. And I'm going to start out doing it by hand, and if it gets too daunting, I am kind of already getting tired, we'll put it in the calculator and let the calculator do our work for us. So let's just try it. We're going to start out with the first one, -3/2. And so I'm going to try to just use this function and see if it's a little bit easier. And if not, we'll go ahead and pull out the polynomial form. So let's see, it's 3 halves minus 1 quantity squared. And this is -3 halves plus 1 quantity squared. Okay, so let's see if I can get equivalent fractions real quick. Let's see, -3 halves. So this is -3 halves minus 2 halves. 1 squared. -3 halves minus 2 halves. 1 squared. I probably shouldn't have done that extra step. -3 halves. -5 halves quantity squared times, it's like negative. Wait, that's a plus. Good thing I caught it. That's -1/2 quantity squared. So -3 halves. I think we're going to use the expanded polynomial next time. This is 2 negatives making positive. So -5 squared is 25 over 2 squared, which is 4. And let's see, -1 squared is 2. 2 squared is 4. And then when you multiply fractions, you're multiplying the numerators and denominators. So we've got 25 times 2 is 50. And then 50 times 3 is -150. And then 4 times 4 is 16, times 2 is 32. And then we could actually, let's do this. Let's cancel some of these out and get interesting. That makes it, -75 over 16. I think that's a little bit closer to reduced form. So -75 over 16. That was a lot of work to find that point. But we have to know, and we have to be, not only do we have to know how to do it, we need to be well practiced. So it's good. This is good, even though it's hard. 75 divided by 16 is 4.68. So that's negative. So we're way down here. No. Good thing I erased down there, huh? Because we need it. All right, so that would be getting a little loose with the points here. So that would be -1. Put -3 halves. We'll move that down a little bit. We'll make it -2. 3 halves, 4 halves, 5 halves. -3. 6 halves, 7 halves. -4. A little bit further down, we need -8 halves, -9 halves. Okay, so 75 over 16 is about -4.6875. Okay. So that's going to put you, that was -3 halves out here. I'm at all the way at 4, all the way down here. Because -9 halves, yeah, that's 4.5. So it's a little bit past that negative. That looks good. All right. We got one. Yeah, I'm not looking forward to calculating radical 15, but we'll do it. Let's just do it. Okay. So the next one, because we have -1 and 0, so we're going to do this next one. So x equal negative radical 15 over 5. So this equals, we're gonna use, let's use this one. So we've got negative radical 15 over 5 to the 5th power. And then we've got -2 times negative radical 15 over 5 cubed plus, it's like just radical 15 over 5. And negative radical 15. Okay, I can leave off the negative because I know it's an odd amount of negatives, so it's going to be negative. And I can just focus on whatever radical 15 over 5 to the, I guess, the 5th power would be. So we've got what this is. So you have 15. Yeah, this whole thing is to the 5th power. It's going to make a exponent, or it's going to make a fraction for your exponent. So it's raised to the, does that, I don't know if I can do it that way. Hang on. This is radical 15. I'm going to have to convince myself. Times radical 15 times radical 15 times radical 15. And I want to see if I get the same. 1, 2, 3. I need one more. 2, 3, 4, 5. All right. So this one. Wait. Yeah, that's raised to the 5th power. Okay. It's a lot to think about. All right. So this is, wait, I don't need to do that. This is 15. This exact copies. So that would be 15 times 15. And then you have a radical 15 left over. I want to see if I did it correctly. We always have to check, right? 15 squared. It's saying 225. Hang on, 225 radical 15. And 5 to the 5th power. That's over 3125. So this is 225 radical 15 over 3125. All right, so just for curiosity, make sure I put it in correctly. Radical. No. Okay, yeah. All right, so we did it. All right, I'm getting lazy. I'm letting the calculator reduce my fraction for me. That is 9. Wait, it's not approximate, it is exact. 9 radical 15 over 125. All right. Holy moly. That's just that one term. That's going to be up. All right. Okay. Which is fine. I need to not be lazy and do the math, so it's good for me. All right. But I'm almost in an hour, so let's go ahead and just let the calculator do its work. All right, that one said, if I can remember, it was 9 over 125. And it's going to be negative, and that's radical 15. And then this one is going to be, it's also going to be negative, but that's a negative. So we're going to say positive. And then this is going to be radical 15. So this is going to be, we'll leave the 2 for now because I don't want to be skipping too many steps. So we got negative 2 times negative 15 radical 15 over 5 cubed, which is 125. Yeah, 125. Which is nice because I so far have the same common denominator, but this one's going to throw a monkey wrench, which is negative radical 15 over 5. This term's going to become positive. So 9 radical 15 over 125 plus 30 radical 15 over 125. And then it's minus radical 15 over 5. All right, let's add these up real quick. 30 minus 9 is 21. Minus 15 radical 5. And then it looks like 5. Is that 15? 25 times. So 25 minus 21, that is negative 4 radical 15 over 125. Wow, that was a lot here. Negative 4 radical 15 over 125. And then the rest of them we're going to just plug in the calculator real quick because I'm trying to sketch this graph and call it good because I realize that I'm almost an hour in. So, got a little carried away. All right, so we've got those points calculated though. Let's go ahead and plug the function in here into the calculator and let's evaluate it that way. It's a little bit better. So we have x to the 5th power minus 2x to the 3rd plus x. And then negative 15 divided by 5 stored for x. Okay, that's a negative 1.2. So at this point right here, at this critical value, because we know we have 0 here, we're at negative. There. We're there. Okay. So let's do the next one. Negative radical, right, parentheses, radical 5 divided by 5. Okay, it's saying it's negative 2.8. So that one was 1.2. This one is right here. Okay. Radical 15. All right, let's go ahead and check. So this one's saying that's negative 0.28. And so let's go ahead and do positive radical 5 divided by 5. Okay, oh yeah, positive. So it's going to be positive 4. Okay, so it's 0.4. It's just slightly below 1/2. This one's down a little bit. And then this one's going to be 0.128. There's your 0, and then 3/2 is going to be a positive 75/16. So it looks like all the way back up here. Here now. Okay, so here's my graph. Okay, there it is. All right, we did it. Okay. And we'll go ahead and we'll call that good. Almost right at an hour, and it looks like we don't have any questions. So again, if you want to see a problem worked out maybe for tomorrow, because I'm going to be here tomorrow, you can post it in the chat, and I'll try to look at my chat later on and see. And I think it gives me notifications anyway, so I should get a notification if you do decide to post a problem. And obviously can't work it out now because I'm late and it's my time up. But just saying, trying to remain helpful, and I'm trying to offer this space up for anyone that may need some math help, and doing it just for fun. And try, and I understand like math brings a lot of hard feelings, and people are insecure about their math, and so I'm hoping to break down some of those barriers, and just have a live math session where no better time than afternoon to be well spent working on some mathematics and sketching it out. So again, I am Professor L, and just want to say thank you for watching my videos, and I will see you tomorrow, same time, same place. Bye.